Hi everyone, so we're going to talk about tangent and the graphs of tangent, and then also maybe graphs of cosecant and secant. One of the questions on the quiz was for what theta does tangent of theta equal sine of theta? So for what angle are the tangent and sine values the same? So if you remember from our special right triangles, tangent, if our angle is down here, tangent is our opposite over our adjacent, right? So it doesn't have anything to do with the hypotenuse. We can also say if we're in the xy plane, right? If we're on our unit circle, or if we're on the xy plane in general, let's say this is a radius of our circle, this is our y value, this is our x value, right? On the unit circle, our radius is 1, and our sine is just our y value, and our cosine is just our x value, because they're both over 1. And so we can say that tangent of theta is going to be our opposite over our adjacent, or our y over our x. We can also say that tangent of theta is going to be, let's say, opposite over adjacent, which is the same as tangent of theta is opposite over hypotenuse over adjacent over hypotenuse, aka, right, this is sine and this is cosine of theta. So we can also say that tangent of an angle is the same as sine of an angle over cosine of that angle. So on the unit circle, it's a little more obvious because sine is just y, right? And cosine is x. But even if it's in any triangle, even if our radius is not 1, our hypotenuse or our radiuses are always going to cancel out here, and we're still going to be left with opposite over adjacent, or sine over cosine. So the reason why this is important or relevant is because if we have our unit circle, tangent of theta is sine of theta over cosine of theta, right? So then it's sine over cosine, or y over x. So tangent here, tangent of, let's say, 0 or 2 pi, same thing, is going to be 0 over 1, or 0. For pi over 2, up here, tangent of pi over 2 is going to be sine over cosine 1 over 0. That is not going to work, right? Red flag should be going off. This is undefined. For pi, right, our tangent of pi is going to be 0 over negative 1, or also 0. 0 divided by anything is still 0. And then tangent of 3 pi over 2, same with pi over 2, is going to be negative 1 divided by 0. Can't do it, undefined. So for what angles is the value of sine of that angle equal to the value of tangent of that angle? And those are going to be at 0 and pi, or 2 pi, because tangent is 0, tangent is 0, and so is sine. Tangent is 0, and so is sine. But at pi over 2 and 3 pi over 2, tangent is undefined, and tangent is undefined where sine is 1 or negative 1, so those are not the same, obviously. When we're thinking about the graph of tangent, I'm going to make a graph like this. This is going to be my theta, and this is tangent of theta. So same way we were kind of graphing sine and cosine last week. If we want to graph tangent, our input axis, our x-axis, is going to be our angle in radians. And our y-axis, our vertical axis, is going to be tangent of that angle. So, like I just said, we can go around our unit circle. If you have it handy, it might be helpful to refer to. If we have tangent of 0, we just said it was 0, right? And then tangent of pi over 2, I'll put 2 pi over here, pi over 2, 3 pi over 2. Tangent of pi over 2 we just said was undefined. So we're going to have a vertical asymptote at pi over 2. Tangent of pi is 0. Tangent of 3 pi over 2, again, we said was undefined because it's sine over cosine, and cosine is 0 at that value. And then tangent is back to 0 at 2 pi. We can also go in the negative direction if we go negative pi over 2, negative pi, negative 3 pi over 2, etc. So again, at negative pi over 2, let's say you started at the positive x-axis and went negative pi over 2, so you went pi over 2 or 90 degrees down. Instead of going up around the circle, you went down around the circle the other way. This would be at the same place as 3 pi over 2, so it's going to be undefined there also, right? At negative pi, that's just the same place as positive pi. It's halfway around the circle. We're going to be back at 0. And then same negative 3 pi over 2, we're also going to be undefined. So I've obviously skipped a lot of points. There's also like pi over 4 is in here, negative pi over 4, etc. And if you remember at pi over 4 and 3 pi over 4 and all of those points kind of in between, at pi over 4, 3 pi over 4, 5 pi over 4, all of the tangent values are either 1 or negative 1 because our x and y values, our sine and cosine values, are the same or the negative of each other, right? They're either root 2 over 2, root 2 over 2, or some kind of negative root 2 over 2, positive root 2 over 2, depends. So they're either going to be positive or negative 1 for tangent. So tangent of pi over 4 is positive 1, right? Because it's going to be negative, or it's positive root 2 over 2 divided by positive root 2 over 2, right? At 3 pi over 4, it's going to be negative 1. And then we can kind of keep going. We're going to have points like this and like this. It's going to keep following the same pattern. And for sine and cosine, right, our range had a restriction of -1 to 1, right? We weren't going to go beyond that. But like, let's say, what's the tangent of pi over 3? It's going to be root 3 over 2 divided by 1/2, which is just the square root of 3, which is more than 1. So we already know that our tangent is going beyond that. And we have these vertical asymptotes that are kind of helping us make our graph. And if you keep putting in points, you can put in other points that are not on the unit circle per se, like something that was like really, really close to pi over 2, like let's say it was 49 pi over 100, something super, super close to pi over 2, but not quite pi over 2. You would get a really, really, really large number. You can try that on your calculator if you want, make sure you're in radian mode. Or if you want to do it in degree mode, you would get a similar result, like if you did tangent of 89 degrees or 89.5 degrees, for example. But so these graphs are going to look kind of like cubic graphs, but not quite because they approach asymptotes, but they have a little bit of a saddle whenever they cross the x-axis or the theta axis. So like this is going to keep going like that. They should all look the same. My drawing is definitely not perfect. But we're going to have infinite little tangent squiggles. So one period of tangent is actually from negative pi over 2 to positive pi over 2, or 1 pi. You could also say it's from 0 to pi. We would be like we've completed one full tangent squiggle. This one's just broken up in half, and the complete one is from negative pi over 2 to pi over 2, or from pi over 2 to 3 pi over 2. But so the period of tangent is going to be 1 pi instead of 2 pi. So it's half of the period of sine and cosine of theta, because you can kind of see it when you're going around the unit circle. Tangent is going to go from positive to negative from the first to the second quadrant, and then when we enter the third quadrant, it's going to go from positive to negative again. So it's going to repeat all the same values throughout the third and fourth quadrant. So it actually only takes half of a circle, or 1 pi radians, to complete a full wave, if you will. So this graph is a little bit different, obviously, than sine and cosine, because the domain is restricted every multiple of pi over 2, right? Every integer multiple of pi over 2. Nope, that's not true, because if you multiply it by 2, you get pi. How should I say that? Every odd integer multiple of pi over 2. So if you go back to when we did sequences and series, woohoo, it was, we can say would be pi over 2 times 2n plus 1, which is all the odd numbers, where n is an element of the set of all integers, which is what that z means. It can be positive or negative. So there's going to be a vertical asymptote, right, at every odd multiple of pi over 2, 3 pi over 2, 5 pi over 2, etc. So it's going to be undefined at all of those places, right, at all of these vertical asymptotes. So the domain, right, is restricted. It can't be any of those values in yellow. It's going to be all the values in between those vertical asymptotes. But our range, for example, is unlimited. Our range is going to go from negative infinity to infinity. Is all real numbers. Yeah, so that's a kind of a quick explanation of the graph of tangent. And often when we write it, we really just draw the middle one. We usually just draw one period. We just go from negative pi over 2 to pi over 2. And we draw it going through the middle. So it looks kind of like that. But there are infinite tangent curves. So it keeps going like that. But if you see a graph of tangent, often we just graph the middle one, just for showing the different values, and it's basically one period of tangent. For cosecant and secant, they are similar. We won't go through the whole thing as much, but so if cosecant of theta is 1 over sine of theta, right, we're going to have undefined values wherever sine is 0. So if you have your graph of sine, right, and we have at 0, let's go to 4 pi. And we have 2 pi, and we have 3 pi, pi. So, and then everywhere in between. So at every multiple of pi, right, sine is going to be 0. So we kind of look like this, and so on. And so every place that sine is 0, our cosecant value is going to be undefined, right? So we're going to be undefined here, 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 here. So we're going to have these vertical asymptotes. So similar to the tangent curve, where we're going to have these gaps in our domain, these things that we have to skip because it'll be undefined. But now also we're not going to be just limited to -1 and 1. It's actually going to be the reciprocal, right? So anytime we had a fraction, now we're going to have a bigger number because we have 1 over that fraction. So, but also anytime sine is 1, cosecant's also going to be 1. Anytime sine is -1, cosecant will also be -1. So these points are going to be on there. And our graph actually ends up looking kind of like repeating parabolas. And if you graph more points, you'll see it. But it's kind of like these parabolas that go back and forth, and they reflect almost the sine curve, and then hug the asymptotes. And secant is going to be very similar, but just with cosine. So secant of theta is 1 over cosine of theta. So again, anywhere that cosine is 0, cosine of theta, anywhere that's 0, so that's going to be at pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, etc. Any place that cosine is 0, we're going to be undefined, right? Because the cosecant graph kind of looks like, oops, kind of looks like that. Yeah, where this is 2 pi and that's 0. This is pi. And so for secant, it's going to be undefined anywhere it crosses the x-axis. And it's going to look very similar to the secant or the cosecant graph, where we're going to have these, again, anywhere cosine is 1, secant will be 1. Anywhere cosine is -1, secant will be -1. So we're going to have these little u's that kind of look like parabolas, but they're not because they hug asymptotes, which make them different, but they kind of look like that. And then they touch the cosine graph just at that point, either 1 or -1. Yeah, so thanks so much for listening and tuning in. We switched up the style of video today. I hope I did Salman Khan proud with our new video. Let me know if you have any questions or want to talk more about tangent, secant, or cosecant. Woohoo!